Application of fuzzy logic optimization algorithms for navigation problems. The problem in the autonomous navigation of mobile robot is to define a strategy that allows it to reach the final destination and avoiding obstacles. Fuzzy logic is considered as an important tool to solve this problem. It can mimic reasoning abilities of the human being in navigation tasks. In order to achieve autonomous navigation of mobile robot and to avoid such a criticism, our work proposes fuzzy control architecture based on two tools, fuzzy logic and evolutionary approach. A number of criteria of fuzzy logic justified the choice. Among them is the principle of regulation and control by fuzzy logic approach to human approach, in the sense that the variables are not dealt with logical variables but linguistic variables. Close to human languages, these variables are treated using rules that refer to certain knowledge of the behavior of control system. Also, fuzzy logical laws to take into account the uncertainties from sensor data and consequently the environment in which the mobile robot embedded. The mobile robot localization diagram is shown in the figure. The basic structure of fuzzy controller is composed of three tasks: fuzzification, second one is inference, and third one is defuzzification. The first step to realize the fuzzy controller is fuzzification, which transforms each real value inputs and outputs into grades of membership for fuzzy control terms. A second part is fuzzy inference, which combines the facts acquired from the fuzzification of the rule base and controls and conducts the fuzzy reasoning process. These are some methods of fuzzy inference depending on the uses and the form of membership function. When the input and output variables and the membership function are defined, the fuzzy rule is presented as the following form: if antecedents, then conclusions rules. The third part of fuzzy logic is defuzzification block. The objective of this part is to transform subsets of the output which are calculated by the inference engine. The developed fuzzy logic controller for navigation task uses two inputs, the distance d and the angle orientation theta. The output of the controller are the speed of the right VGE and the left wheels VL, VR and VL. The values of two inputs are given to the following equations: d equal to root of xt minus x whole square plus yt minus y whole square, xi equal to theta t minus theta I, theta t equal to tan inverse of yt minus y divided by xt minus x. Figure 3 illustrates the block diagram of a robotic system using fuzzy controller to reach desired position. The final intelligent control loop, that is the block diagram representation, is described in figure 4. In figure 3, it describes methods of conventional tracking fuzzy control system. Navigation fuzzy logic controller, the inputs are distance and angle, output is VG and VL. Fuzzy rule base is given, Sugimo model, and block diagram representation is given in figure 4. In that x, y, theta is fed back to the error detector and gives a error, and controller before the controller calculate the path. So, D and xi is calculated, that is given to the physiologic controller. Physiologic controller put given as VR and VL, which is given to the mobile robot. VR is right side wheel voltage, L is left side wheel voltage. Based on that, wheel moves, and present position is again fed back to the error detector. Thank you.